Hello again, my name is Eduardo. We're gonna do the second video of our series. And in this one, we are gonna be taking data from files and be able to incorporate into our prompt so that we can get some actual analysis going on. So I'm not doing anything crazy, but this is the foundational to understand why vector databases or agents are very useful and how they can help us facilitate and make it a lot easier to do the analysis of all this data. I have I have created a couple of PDF files that are going to serve as our data source. I have a CSV file that has data. We're going to use that to be able to then create a little bit more useful prompts, if I may say it that way. Okay, so let's go ahead and share my screen here. So gotta go here, and we are here. Perfect. I have created a couple of files now. This is my second one. I have my requirements and I have my folder. You'll see the folder that has 3 PDFs and 1 CSV. So these PDFs are really have some specs about each one of these machines, bulldozer, excavator, and forklift. Now, these represent a lot of the documents that an organization may have. It can be HR policies, IT policies, or actually documents about how the product works. So that's kind of like the idea here. So how we're going to read this? So first of all, in order for me to read these documents, I need to bring over here. I'm going to bring, I need to use library call. Let's see here. What happened here? Yes. Okay. I'm going to use PyPDF. And this library is going to help me actually, it's going to help me read this PDF file. So I have my AWS GenAI app environment following from content from our previous video. And so if I do this, of course, I don't have this module yet. So let's install it. It's going to install it, and I'm going to go ahead and I'm going to add it to my list of libraries or packages that I need to upload. Okay, perfect. So it's there. I'm going to rerun this, and now it's in here. Awesome. Okay, the next thing that I'm going to do is I'm going to load the file, and I'm going to put it in here. So I'm going to do this. So reader pydf.pdf reader, and I'm going to give it the location of the file. So I'm going to do that. Perfect. Okay. So the next thing that I can do is, okay, let's get the text. Let's get what text is inside in here. There is a few things that you can do, but for our purposes, we actually want the text. Okay, so that's the text. Awesome. It has some information about this. So this is the forklift. Okay, so what I'm gonna do is I'm gonna go ahead and I'm gonna do text equal, and I'm gonna do this. So I actually can put it here together. Now, let's take a look here. The operational data is for the bulldozer 001. So let's do something. Let's change this, and instead of the forklift, let's add it for let's load the data for the bulldozer. So I'm going to change this, and I'm going to actually change it for the bulldozer. And I'm going to go ahead and I'm going to read this. Perfect. So now this is the bulldozer. This is information for the bulldozer. And then I'm going to put it in here. Perfect. So I have the text now in my file. All right. Now, what can we do with it? Okay, well, remember what we did before? What we can do is actually build our prompt. So I'm just getting the code from what we had before. And so I'm just going to get the client runtime. So I need to import Boto3. Remember the library to be able to do this. Then Bedrock runtime. This is the one that will allow us to interact with the model and then the system. Now, in here, I'm going to change it. I'm going to do something more particular, more useful for what we are doing here. So what I'm going to do here is you are an expert in heavy machinery and machine use for construction. You can explain machine spec information clearly and make it useful. Okay. So this is something very still quite short, but I'm giving it a little bit more framework as to how I want, what type of data, and what is the role that I want this machine or this system to actually use. Okay. So then what I'm going to do is I'm actually going to create my prompt here. And this is where we're going to combine a little bit of what we had done before. So I'm going to do, and I'm going to say, okay, give me a summary of the bulldozer in this piece of content or based on the bulldozer, based on the following data. Right. Now, what we're going to do, remember, I have my format or my f string in here. And so what I can do here now is I can do text. My variable is text. So what is going to end up happening is that it's going to add all this text into my message. So for example, if I do print messages, you could see here that now it's adding all this data into it. Okay, so I'm not formatting, I'm not doing anything additional to it. I'm just passing the data to the model. And that's what I'm going to do. I'm just going to pass the data to the model the way it is. Okay, I'm going to do the inference parameters. Now, remember, I'm just going to increase it to about 500. Now, I want it to stay as close as possible with a little bit of room. So I'm going to bring it down to 0.3. And for the creativity, I'm just going to bring it down to 0.4. So I'm going to do that. I'm going to run that. And then I'm actually going to run the inference here. Oh, okay, of course. I forgot my model ID. So, okay, I need a model ID here. So what I'm going to do is I'm going to come back here and I'm going to go ahead and I'm going to get my model ID again. I'm just going to copy it, the version that I have here. Okay, perfect. This is what I'm going to use. And I'm going to come back here. It's going to add it just before here. Perfect. And I'm going to run it. Now it should work. It's running. Nice, it worked. Right. And then I'm going to get the information preprint. I haven't imported my preprint here, so and then I'm gonna run my response. Perfect. So I have all of this data, and what I'm getting here is a summary. Awesome. Okay, let's see if we can make it a little bit nicer on this side. And so let's just do this last one instead of the entire thing. Okay. So let's see what the model can tell us. Okay, so this is a summary. Nice. Nice summary. It's not something special, exceptional. Let's see if I can make it scrollable. Perfect. So it's gonna go up. Sometimes it's a little bit okay. So it's an exceptional machine. This is the key specifications. That's the performance design and the key features. All right. So we have that. Now, as you can see, we are able to upload the PDF and get into here. But that's only one. If you want another one, then you have to do this again. And then depending on the questions, you may ended up having to upload different things, and it can get complicated into understanding which one it is. Which one is the one that you need to upload? Now, technically, you can do it by, let's say, getting the question and telling the LLM, hey, first thing that I want you to do is classify if this is the bulldozer, the excavator, or the forklift. And then the LLM will tell you, oh, this question is about the excavator. And then you can go have logic here and say, if the response is excavator, then go and upload this and then answer the question. But that's not very efficient because then you have to do the call. What if it's something completely different? Or what if you have 1,000 documents? You're not going to have a classification of 1,000 documents. or even more documents. What if some documents are very similar to others? How will you differentiate between them? And well, there is a lot of different logic behind that. So it gets complicated in that sense. So one of the things that we're going to do in our next session is how do we make this a little bit easier to look up? Okay. But before we do that, we are going to finish this one because we have this, but also we have the CSV. So we have the PDF with some information about the bulldozer, but also we have this operational information. So it tells us the date, how many hours it operated on that day, the fuel consumed in liters, any idle time in hours, materials that it moved in cubic meters, and finally, any maintenance flags. So we have this additional data. Now, of course, it's synthetic, but you can imagine that you may have this data in your organization that is quite similar or that is maybe different, but it's this tabular data that you have, right? So how can we do this? Well, let's go ahead and let's import in CSV. Perfect. And then we're going to open this with open data sample, sample operational.csv. Now I'm going to open it. I'm going to read it. Just read like that as f. And then we're going to put it into our variable data. Let's do operational data. Data equal f dot read. Let's see if that comes through. And then let's see print operational. Oh, cannot type today. Okay, operational data. There it is. Okay, we have it in a variable. So now what are we going to do? We are going to combine it with our previous prompt. Okay, so what I'm going to do here is, okay, let's do this again. Okay, this is a system. I'm just going to go ahead and copy it down here. Perfect. Actually, so it's a little bit easier. Let's split it and let's have it side by side. Okay, so I split it so I can copy it easier. Okay, so I have my system and then I'm gonna put my messages. Okay, this is my prompt, my actual prompt. So here is what I'm gonna do this a little bit different. Okay, so my prompt, give me a summary of the bulldozer based on the following data. Okay, let's change this. Give me an analysis of the bulldozer. Okay, let's see, an analysis. This is of the bulldozer based on this specification. Okay, so that's my specification. So what I'm gonna do here is a little bit different. So I'm gonna actually make it into a multi-line. So I'm gonna go ahead and do this. And then I'm gonna just make this 1, 2, 3, perfect. And one of the things that I'm gonna do is I'm gonna use a little bit of Markdown and I'm gonna do spec data. And then, so give me analysis of the bulldozer based on these specifications. Actually, I'm gonna change that a little bit. Based on the specifications below and the operational data. Perfect. So now I'm gonna do here specifications, and then I'm gonna do operational. Perfect. So I'm gonna put my operational data here. Okay. So this is my entire prompt now. So I have my text, which is the PDF that I read already, and then my operational data, which is the CSV file. Now, the next thing that I'm gonna do is I'm gonna go ahead and I'm gonna do my inference. Beautiful. I already have my model ID, so I don't have to do that one. And then I'm gonna do my actual inference. So it's running. Everything is looking really good. And then finally, what I'm gonna do here is I'm gonna print the response. So I'm not gonna print the response, but just the actual output. Okay, let's see what it can give us. So this is analysis, this is the key features. And then it's gonna give us the operational data analysis, summary of operational data. Total hours operated is 142, 75 of total fuel consumed, average hours per day, perfect, and average fuel consumption per day. So now there is a little bit more data here. So it's telling me how fuel efficiency is calculated. So it's giving me that calculation there. Nice. Then, okay, and then it's telling me this efficiency aligns with the manufacturer's claim of up to 8% improvement in fuel efficiency. So it's giving us analysis about this. Now, of course, this is synthetic data, right? This is, I recreated the PDF and then I created some CSV files. But you can see how we can start utilizing this to be able to give us some additional information and some metrics. Now, if I have a lot of different data, well, this is not going to be, how can I put it? It's not going to be very useful when I have a lot of documents that I have to compare it to. So that's something that we're going to look in our next session, which is the rack system, how we are able to handle a lot of these documents. But something that you can see here is that we are able to integrate the data into it. And I have deployed many solutions into production that do that. They have a Lambda function, they retrieve data from an API or from a relational database for a specific period or a specific function, get it, and then we ask the LLM to analyze it. So in this case, something that I can do is tell it, okay, give me analysis of just operational data, then compare it to the key features, and then tell me what else can you do better or what improvements can you do. So for example, I'm just going to combine all of that into here. But when you have a lot of data, you will need to split it because it won't fit into just one analysis. In this case, it's a small, so I can fit all of these into one into one call. But in your case, if you have a lot of data or the amount of instruction is a lot, then you may want to split it into multiple steps to do one thing at a time, and that will give it better focus, and you will get better, what is it called? Better results. So I misspelled this specification, but I'm still got it fine. That's really great. Okay, so give me an analysis of the bulldozer of performance evaluation. Let's go with a performance evaluation. Performance evaluation. So this is a little bit different of the bulldozer based on the specifications below and the operational data. It's going to as well tell me any opportunities to improve the performance of the bulldozer. Perfect. So I'm going to do that and I'm going to run this. We're going to see a little bit of the answer. So I'm going to leave this one here. Then what I'm going to do, okay, perfect, that run. I'm going to leave this one here and I'm going to run this one below. Now, let's see what it does. Performance evaluation is a little bit different. So it's giving me a little bit of overview of the bulldozer and the model that I have. But right away it's telling me about the operational. It's not giving me about the specifications. It's already giving me about the operational data. It's telling me about the fuel consumptions, the idle times, and then it's going into the performance analysis. Okay, let's improve this. Performance analysis efficiency. So it's materials moved per hour, 1,400 cubic meters per hour. Fuel efficiency, 0.042 liters per cubic meter of material moved. So you can see it's giving me some interesting data points. It's performing well in terms of materials moved per hour, which aligns with its design for moving large volumes of material efficiently. The next thing is fuel efficiency. The fuel efficiency is slightly higher. They advertise a percent improvement over previous models, indicating good performance in fuel economy. Fantastic. And then the idle time is relatively low, suggesting that the bulldozer is being utilized effectively most of the time. Fantastic. Is there any opportunities for improvement? Well, reducing idle time, opportunity further minimize idle time by optimizing work schedules and reducing downtime between tasks, implement better, and it cut off. Why? Well, because what we have here is that we have a maximum of 500 tokens. So if I wanted a little bit more, then I will increase it to maybe 700 or 1,000 and then do that. So I will let you do that to see what is the difference that you will see. What is the different performance? But something else that you can do is connect it, maybe have a function that calls a database, its data, and then input it into the prompt for analysis. And so it's very, very cool, some of the stuff that you can do. As you can see, everything that we are doing here is building or getting the right data into the model. And you can use, there's a few techniques. One is that you can use a markdown to be able to separate your different parts of the prompt. Another one is to use XML tags. And so, for example, in this case, I will use something like this, the specifications, and then I will do something like this. Sorry, specifications, and the same thing for the operational data. You can do the same thing. And so you can either do Markdown or you can do this. Now, the other thing that you can do is also ask it to give you the data in a specific format like JSON. So I can tell it, give me the analysis in properly formatted JSON. Now, I'm not specifying which, like what keys should be in the JSON or how the JSON should be structured. I can definitely give it an example of that, but I'm not going to do that. You can do it as an exercise. So if I run this, now something you will see here is that, okay, so this is previous one. This is my analysis, operational analysis. Now we're going to see how it looks like in JSON. And as you can see here now is a JSON format that I'm able to parse and be able to do something with it. So you can now take this output, parse it over another function, and be able to put it either in a database, put it in an email, format it the way you want to, or put it in front of a UI and do what you want to. So it is quite powerful, the things that you can already do with this. So like I was mentioning before, you can connect it to a database and be able to extract data and do analysis. This is especially useful for batch inference. So maybe analysis of your customers' data every month to see what is performing well, what is not performing that well, and be able to take action based on that. Maybe, you know what? Maybe you have consumption of your cloud spend. Can you analyze that? Can you get that data out and parse it over to the LLM to tell you, hey, these are items that you should be looking at right now to be able to do this or to be able to make improvements. Okay, so that is what's going on. And one of the things that we're going to take a look at next is what is a vector database that will allow us to expand all these PDFs into larger PDFs and even more amount of PDFs and be able to still extract the right data out of it so that we can give additional knowledge to our LLM model and be able to do even more things with it, right? So right now, I'm enhancing this analysis with this PDF, but when you have large amounts of data or PDFs or HTMLs or documents, then it becomes a little bit harder to enhance that knowledge of the LLM. If I didn't have brought I haven't brought what is it called, the PDF into my prompt, it will not give me as good a response. So let's say that I don't have the specification. Let's remove this. And I'm going to be changing this a little bit based on operational data. Let's say that I only have the operational data. So I don't have context about the specifications of this model. Okay. So I'm going to go ahead, I'm going to do this, and I'm going to run this again. Okay. I'm going to not remove everything else that I have done before. So you can see it in the repository when I upload it. Okay. So now you can see here that it's giving me this. So it's telling me just very generic, reduce idle times, optimize fuel consumption, conduct a fuel efficiency audit. So it's not telling me anything about that this is good or bad. It's telling me to what it actually do and increase operational hours. So schedule it. So it's a lot simplified analysis than before when I have the specs. The specs, it was giving me a lot more specific information about this. So for example, the average consumption is this. Implemented field 7 techniques and optimization operational practices can help reduce fuel consumption even more. So it's not telling me to do not it. It has the specs and it can give me a little bit more information about that. These additional information that I can give it, these PDFs and these other documents definitely help. And that is something that is very, very useful. So next time, we're going to start implementing a vector database. We're going to start seeing how this works, what are embeddings, how do they work, and how we are going to be able to make very efficient use of these embeddings to enhance the knowledge of our models. All right. So until next time, keep having fun, practice, see where you can connect already, and we'll talk in our next video.